Okay. Let's see, Streamlab. Okay, it's working. Let me see. It's working. Okay, stream. All right. So what's gonna be on the test? You are gonna have to require the graph a piecewise function. You have to graph piecewise function. Like with absolute values. Okay, absolute values. Yen, just leave my class. If you're gonna fall asleep, just leave my class. Or you stand up, you write down shit down, or you leave my class. Because I don't have to spend other people's effort to wake you up. You have to be the one that consciously want to stay awake. So you stand up or you work. You write things on the board. You stand up, you write things, whatever you do, you stand up, you make sure yourself awake. But if you're gonna fall asleep, then don't need to be here. You can fall asleep somewhere else. Go to your mom's room, you can fall asleep there. And that's probably the best place to fall asleep. Because she would throw a marker at you. I'm too lazy to throw. Okay. You gotta be able to graph absolute values. Parabolas. You have to know those units like 0, 0, 1, 1, 2, 4s. Basic parabola units. Basic absolute value units. Okay? You have to be able to evaluate. So you're gonna get the question from last time before. For sure. You're gonna have to know how to do projectile functions. Which is, I'm gonna ask you axis symmetries. Vertex. X-intercept. They all represent something else. X-intercepts represent what? When the things what? Fall on the ground. What's a vertex? Highest point. Where's axis symmetry? The time reached the highest point. Thank you. So those are the things. Can you complete the squares? You can get two things with one. You can get this two things at once. Can you graph vertex form? Can you graph standard form? Can you graph fractal form? Can you graph Euler's form? Fractal form give you x-intercept, right? How do you find a vertex form from fractal form? No. From fractal form, how do you find a vertex? Huh? No. McKenna?
When you distribute the factor form into
you can do that, but that's way too long. Yes, Safa. Average of 2x intercept. Do you guys remember that? P plus Q over 2. Thank you. Why? Because you stand on the 2 points. Your head has to be in the middle. Do you guys remember what we talked about it? Okay, fractal form. In order to get the axis symmetry, is the average of 2x intercept. This is a very important. It's always tests on SAT, always tests on my class. You can plug in a value to find the vertex. Standard form, vertex form. Vertex form is just H and K, and see are they facing up or facing down. You are gonna get a unstructured question tomorrow. I'm not gonna tell you what. It's actual SAT questions. But I'm not gonna tell you what does it look like. You guys have to figure out on the spot. So yeah. Can you use quadratic formula? You probably have to use 2 or 3 different ways. You can find inside I, or inside 0, or inside a number. So if inside is a number, you're gonna get 2 solutions. Inside is 0, then you get 1 solution. If inside is a negative number, you're gonna get complex solutions. So you're gonna get all that. Can I give you given a vertex and a point? Can you find the equation? Giving 2x-intercept and a point, can you find the equation? Do you know what I'm talking about? You did this homework twice already. Like I said, you want to know what's on the test, everything's on homework. Can really help you if you don't willing to help yourself. Yes.
Are you going to give us a review for
No. I don't know. The first idea is come to is no, because I don't appreciate people don't do homework. If you do your homework, if you just go look back your homework, you should be fine. I don't want to keep on issuing your homework. You're just doing the same thing over and over again. That's not how you learn math. Learn math is you learn once and you know what's going on and you learn what you're missing. I don't know. I might change my mind throughout the day though. But for us right now, I don't want to issue you. You could have just go back and look at last Thursday, last Friday's homework. Everything's on that. It's not. I'm an open book. You guys all know taking how many tests already. All the test question is on that. It's based on homework. The only question that is not on that is unstructured question, but you guys have to figure that out. But if you do it so well on your regular question, unstructured question should be fine. So if you don't do your homework, that's where you get caught. Okay. Pretty much that's it about anything about quadratic. Okay, so let's talk about what's gonna be on laid out. So we're gonna go to talk about out of parent functions. And this is out of parent functions. So we already know a few. We already know x, that's just a line. We already know x squared, that's a parabola. Look like a U. We have f of x equal to absolute value x. It looked like V. I'm going to talk about the next one. F of x equal to x cubed. Does anybody know what this graph look like? What is squiggle?
Isn't it like it turns and turns again?
It turns and turns again, okay?
The odd functions.
It is. So I'm going to talk about this one. It is odd function. Good job. -2. That's going to be -8. -1. 1. 0, 0, 1, 1, 2, 8. So it's going to be like this. I think. Some people call it squiggle line. I have a specific name for each graph. It look kind of like a waterfall. If you ever go to like a waterfall, it kind of have a in middle waterfall has a pause and then fall again. I call it a waterfall graph. So that way you know. And there's points that what happened, it's gonna be based on the same thing. Bennett point out this is the R function. He's correct. Domain and range is going to be all real number because it can expand y as it can. And range is going to be negative infinity to infinity. There is a point here we're going to call, yeah, whatever point you want to call it. I call it anchor point. Anchor is where the transformation happened. So it's 0, 0. Even though math doesn't call it anchor point, I call it anchor point. It's because there was a teacher online that she did a blog, and I really enjoy her blog. She called it anchor point, and it makes sense for me. So this is our function. I want to start talking about what happened to M behavior, so that way you know. So let's just say talk about parabola first, right? Do you guys ever hear the term M behavior last year? What does that mean? No? Okay, so I'm going to show you how M behavior works this. Robert, you got to look at here, otherwise you know what's going on. Stop playing with your phone, I'll throw it out the window. Okay, so M behavior is, look at this, right? If you go in this way, it's going to go down, and this way it's going to go up. How does M behavior works? There is a going left and right. How do you go in left and right? So we're going to use the idea called limits. X approach negative infinity. Think about it. X going to negative infinity. Is that going left or right? That's left, right? So this means left. The function going to the left. And I'm going to show you how to do a function going to the left. Right. I'm start teaching you pre-cal stuff now. Past infinity. This means right. Is that okay? So how does this work? How does this M behavior works? As a limit x approach negative infinity of f of x. Why you need an f of x? You want to find out what happened to y value when the function going to the left. You have to write on the bottom the x approach negative infinity. The function is going where? No. Down. So what does that mean? Down means negative infinity. Limits as x approach to positive infinity of f of x is equal to positive infinity. If you don't understand, ask a question now. Because later on you're gonna be like, what is this? Yes. LIM is called limits. Good question. Limits is how you're gonna start writing M behavior when you start from now on. It used to be x approach to infinity. As x approach to infinity, y is equal to this. For pre-cal, it's gonna be a little bit different. as x limits as x approach infinity. Damn it, Ian. Ian, leave. No, then stand up and write down stuff. As limits as x approach negative infinity, that just means the function go. Get your ass up the chair. Because you're gonna fall asleep the next second. I don't care. Limits as x approaching negative infinity. That means function going left. Limit x approaching positive infinity, that means function going right. In this case, as limit going to the left, the function is going to go down, right? And the other way is limit x approaching to positive infinity, the function is going to go up, which is positive infinity. F of x just means y. So you can ask me any question right now. You should have a lot of questions. Armin had a question. Go ahead. X approaching an arrow. So let me write it bigger. So for this one, it's going to be limits as x approach negative infinity. That means function going to the left. What happened to the output? Output is what? Down, right? Left, down. Right. It's going to be up. And that's how the XQ graph is going to go. If you have a question, ask now. If you don't understand anything, now is a good time to ask. Because not a lot of you guys understand this notation yet. Yes?
So if the graph was basically reflected, how would you?
That's a great question. See, Charlotte is pointing out a really great question. She's thinking about a question. I heard a mathematician say it once, a long time ago, that there's a German mathematician. It says people should value question more than answers. I value that question more than any answer that she can come up with. What if it's negative x cubed? So I want to challenge you to write M behavior for you guys. What if it's negative x cubed? What do you think the graph's going to do first? Bennett, what is the graph going to do first?
It's gonna be increasing y when it's decreasing x.
You gotta say that clearly. I don't know what you're saying.
It'll like flip over the y.
Flip over the y. I like that. Okay, so flip over the y. It's gonna look like this. So it's gonna look like this. So I challenge you guys to write an M behavior for this one. How would I write M behavior for this one? Write it down first. Check with each other if once you finish.
Yeah, so I guess that's yeah, so I guess the y value is increasing, and then as x is decreasing, it's like the y value is yeah.
So the function going left. Think about what happened. I'm going left, right? If I'm going left, what happened? It's gonna go what? Up, right? So left, it's gonna be like this. This is left. But you have to write down f of x. You cannot say don't have f of x. That's equal to past infinity. That's how you write it. That's end behavior. As limit x approaching to infinity of f of x is what? Negative infinity, and that's a proper way to write it. Yeah, approach it, x approach infinity. That's how you're gonna write it. Limits as x approach infinity. Okay, so the next one. How about if I have this? How would I write this? How would I write end behavior? Well, what does the drawing look like, first of all? And what does the end behavior look like? You guys gotta learn how to draw. Robert, no? Parabola facing downward. Okay, let's start with that first. And it has to remember this 4 unit is 0, 0, -1, -1, -2, -4. So it's gonna be like this. Okay. So the end behavior, let's see if you guys can write it correctly. If you write it, check with your group members, see what they get. This is something we've done before. So check each other, see what they get.
That would be the one. Yeah, that'd be the one. Do you do the left side first? Or and then the top one is going or would that be going down?
So this part describes like whether it's going to be right or left. And then this part describes whether it's going to be wrong. So like if you look at here, it's like x is it a purchase thing? It's on the left side. So I guess they're gonna have to do right? And then you look at this and it's saying positive today, meaning that the y values are increasing. So then like if you look back down here, it's saying like if x becomes negative, then y will that's why this is negative. But on this side, all the x values.
All right, so the discussion's good. I hear a lot of discussion going on. First, I always go into the left. It's just my habit. It's like I write down domain. I write down from negative infinity to positive infinity, so I write left first. But I will never forget this f of x because f of x has to be there. And that's equal to what? If limit x approaches negative infinity, what happened? The function. Negative infinity, and then what's the other side? Good. So you guys are both doing great. Okay. So now we know x squared, x cubed, x. What's the next function I need to know for parent function? We already know absolute value. What else? How about f of x is equal to square root of x? Well, square root of x, you're gonna plug in some values. I'm gonna plug in negative number. What happens if I plug in negative number? Square root of negative number is what? It's I, which is it's not able to draw, right? So square root of -1, that's gonna be undefined for now. On a real number is I, but you cannot graph I. So then you say, oh, it's okay. Well, we're just gonna graph start at 0. What happened at 0? 0. What's the next point I can graph? 1. So that's 1, right? What's the next point that you think is gonna give you integers? 4. And then what happened? I'm gonna get 2. Okay, so those are the units I need to know. Is basically it's gonna be start with this 4 units. And this is the graph it's going to be. And we're gonna call this a specific type of graph, okay? I don't know what your Algebra 2 teacher called it. But since I teach calculus, we have to find the value of a football. Now, in calculus, you had to find a value in football. You had to take this graph and you had to rotate around x-axis. And if you rotate, it's going to form a half a football. That means that graph is going to come outside the board and then going to go inside the board. So if you can find the value of that, then that's a half a football. So I call this is a quarter football graph. So if you really think about it, if I draw a football, it's probably look like this, right? It's look like this, right? So I call it a quarter football graph. Okay, I call it a quarter football graph. Why? Because it has a point here. Oops, my bad. It has an anchor point here. The anchor point is going to be right here. Is 0, 0. And that's a point as you're doing transformation. Okay, that's square root x graph. We're gonna start introduce all 12 different parent function, and you're gonna be able to graph all 12, and you're gonna have to graph on a piecewise. So, is this okay? Okay, now I'm gonna talk about how do I graph f of x is equal to q root of x graph. What do you think q root x graph look like? First of all, you should ask yourself, can you cube root of negative number? Yes. So you no longer get I, right? So you're fine. So what is cube root? What does cube root graph look like? Yes, Brandon? And you're not entirely wrong, but you're not entirely right. First of all, cube root is an even or odd function. Odd function. Okay, that's a good start. So what does the graph look like? Kind of. It's not, yes, kind of both. Good job. Kind of like waterfall, but it's on x-axis. So if you look at the x-axis, it will work that way. I call it like upstream. Like, so why, like if you go into, I don't know if you ever go to like hiking before, but if you just like, you're gonna see it upstream. So it's gonna look like this. Because cube root of a is equal to 2. So cube root of negative 8 is negative 2. Negative 1 is negative 1. And 0, 0, 1, 1, and then 8, 2. So it's going to look like this. It's like a waterfall but sideways. So I call it upward stream. Like sometimes you go climb the river up and you see the river is kind of like this and come back down. And that's, you know, that's how I look at it. It's going to give cube root of x. And you guys should all have graphing paper, and you guys should have all graphing graphing calculator as well. TI-84CE. Here, I'll show you. I've got a graph on here. So this one is going to be f of x is equal to cube root of x graph. So how do I go cube root? I have to go function. Oh, I can. So there's another way to write cube root. How do I write cube root if this one doesn't have a cube root graph? How do I do cube root? Yes.
Maybe like to the power of 1/3.
I like that. Power to the 1/3. Why is 1/3? That's a good graph. That's the same thing as a cube root graph. Why is 1/3? Austin?
You turn into the square root. Or
Yep.
cube root, it becomes 3. Yeah.
So this is called definition radical. So you cannot graph this because there's no cube root function over there. So you can change this to x to the 1/3, and that's the same thing. Now the end behavior is still the same. It's still gonna go to 9 infinity. However, it's gonna go down very, very slowly, but it's still gonna go to negative. It's still gonna get lower as x increases on the left side. As x increases on the right side, it's still gonna go to past infinity. It's still behavior same thing as the x cube graph, and behavior is still the same. It's just gonna reach slower. It's not as fast. So as you guys know how much I like piecewise function, now I'm gonna teach you how to graph all of them in piecewise function. So I have f of x. And I'm gonna say, okay, well, it's gonna be x plus x, actually, sure, x minus 5 to the 3rd power minus 1. When x is, I don't know, less than 3. And we got a negative x plus 2. Oh, I'm sorry, this one's plus. Wait, hold on a second. What do I want? Make up my mind, sorry. X. Yeah, x. Okay, let's do that. X plus 1 minus 1 when x is between 3 and equal to 1. And let's say it's x plus 3 square plus 2 when x is, wait, this is a negative 1, and this x equal to -1 to 5, -5. Okay, so let's graph this function. What do you think a first graph look like? X minus 5 to the 3rd power rather than 2nd power minus 1. What does this graph look like? Yes, Armin. It looked like waterfall. Why does it look like waterfall? It's a cube. Okay, so how does a waterfall go? Anybody know how the waterfall go? Yes. Okay, I'm asking what's anchor point. How do I go from anchor point? Yes.
Go right 5 and down 1.
Why right 5 and down 1? Yeah, parentheses opposite. So the transformation happened exactly the same way. So that's gonna go 1, 2, 3, 4, 5, and you're gonna go down 1. So that is gonna be your anchor point. Now remember that x cube graph is gonna look like something like a waterfall, but you gotta understand the units. The unit's gonna be here and here, because 1, 1, and then 2 is gonna be 8. So it's gonna go right 2, up 8. So it's gonna be like here. So this graph is gonna be like something like this. And this graph is gonna be something like 8 unit down. So it's gonna be like something like this. Any questions here? Because remember the unit, the table looks like this. If I go 0, 0, if I go 1 to the right, I'm gonna go up 1. If I go to 2, it's gonna be 8. So that is gonna form exactly like this. If I go right, it's gonna go up 1. If you go right 2, it's gonna go up 8 units. Just like what that table shows me at the very beginning. Just like same thing like a x squared graph, you have to knowing all the unit, how they change. And this one is gonna the other way, because the R function is gonna go the other way. Is that okay so far? Am I going too fast? What's the next graph? What we name them? This is, we call it this waterfall. What's the next graph going to be? What is it? It's a quarter football. Okay. So where's the tip of the football goes? Going which direction? They still follow inside the parenthesis, and inside the parenthesis this time is radical. They still behave the same way. So it's something to the 1/2 power the same way. What does a graph do? The tip of the football is going to go which direction? Down how many units? How many units to the left or right? Left 1. Good, because this is a positive 1, so it's going to go left 1, and this is down 1. So, okay, well, so far so good. So this anchor point is going to happen right here. Is that okay? Now, the tip of football is going to usually go in this directions, right? Usually go in this direction. But since this is a negative, so it flipped. So it's flipped this way. Does that make sense? Because it's negative. So you reflect toward the x directions. The last one is what's going to be on tomorrow's test. This is x plus 3 squared plus 2. What's x plus 3 do? Well, left 3 and what? Up 2. But this graph's going to look like what? Parabola. So it's going to be like this. Wait, hold on a second. It's from -1 to -5. Okay. -1 to -5 is going to be like this. And this is an open circle. And this is my piecewise function graph. And once you graph it, click on decimal, see if you graph it correctly. If you don't know how to do square root, you can do something to the 1/2 power. But as soon as you graph as many times as possible, you are going to continuously have all kind of piecewise function until end of the year. So you got to learn how to graph piecewise function. You cannot just say, I don't know how to do that test. Oh, well, I screwed up. I'm going to go to the next test. I'm still going to screw up because now I'm going to compile new graph in there. You got to be able to graph lines, parabola, square root, everything. Yes?
For the second piecewise, how come it's not across the y-axis?
Oh, because this negative usually cross the x directions. It's gonna face down or face up. It's hard to do cross y-axis, and I don't require people to remember that. But if you want to cross y-axis, be square root of a negative x. It will be inside is negative rather than outside is negative. So that's gonna be like a whole different piece over there. So I don't want to confuse you guys. We just want to have a normal transformation. So we finished two more parent functions.